All right. So I appreciate your patience. Yeah, I had a student in another class, and we had to get some stuff squared away. So now maybe it is, but at the very least, I'm able to move on to go to the next class. So there's a good thing. And so what we see here is that today is the 18th of June. So homework set number 9, which was due for today. And then test is coming up on Thursday, exam number 4. And just as before, we're going to talk about the material from homework set 8 and 9. We're going to go over those today. We'll talk about the practice test. Hopefully get everything all nice. And then during the time on Thursday, we'll have some time before the test to start into the next topic. It will take us some time, so there won't be any homework right away for that because there's just too much. So we'll take some other time then that next Tuesday and then keep going. And hopefully everything will turn out fine. I do have your test graded for many of you. There are a few of you for whom I do not have your test graded. I apologize for that, but I figured I'll just get everybody's out there that I have. And then I can finish grading those tests this afternoon and post those on the site so you'll know everything about that. So does anybody have any question about the schedule or anything like that currently? Okay. Now I'm not that great with everybody's name yet. I apologize, but I'm going to try to make this work so that I can hand your test back. And some people are not. Crystal Reed. Alex. Jessica. The Spanish. Laura. Alyssa. Kayla. Adam. Gabrielle. Krista Wright. Lena. Katie. Yeah. Chantal. Casey. Lena. Okay, so the other four. Let's see, we have three because one of them's gone. But anyway, yeah. So in previous times, we've had as many as 27 people get A's on the test. This time it was only 16. So substantial numbers of people who did not get an A on this test who might have gotten an A on the previous. And so then hopefully to be able to understand the reasons why, seems really bright. I turned it down. Okay. So anyway, my webcam's kind of weird. Whatever. Maybe the basic reason why many people did not do well on the test would be the first two questions. Okay. Having to do with the probabilities here for these different things. So we'll go through this just so you're aware. And this is not, how shall I say this? This is not something that you're going to see this way in the future. So this is not a common thing that's going to hang on and be done over and over. Question number 7, the binomial distribution and the bell-shaped curve, that will come back. Okay. And question number 3, finding observed probabilities, that will also come back, but that's good because most people got that right, so then we're okay. But for number 1, there are different forms, whether you have Form A or Form B, depends on what's happening.
Even though mine's not graded, can I have it to look at?
Yes, I can give you a blank copy to look at, because yours is actually on the office.
Okay. Thank you.
Mariah, did you want one to look at?
Sure.
Okay. So if I have, let's just take Form A, I have a box that has 10 batteries. If I have 10 batteries and I have 3 which are charged, then that means I have 7 which are not. Some people do not divide up the thing the right way, but that's how it should be divided up. And then, if this is the case, and then we ask the question, what happens if I take out 2 of these batteries? So if I look at all the different things that can happen here, okay, then normally we did this horizontally, but we could do it vertically. If I have the first battery, these are the things that can happen. For the first one, I have 3 or 7, okay? So then when we say, what happens with my second one if I take that out? If I take out one of the charged ones, that means I have 2 charged and 7 not. And then over here, if I took out a not charged one, then I have 3 charged and 6 which are not. Now, it's not necessary for you to actually make this tree diagram, okay? But in order to actually think through the process of what is happening here, it's important to be able to organize your information here a bit. So, Rachel, I have your test here. So, the question is saying, what's the probability of getting only 1 charged battery? And there are actually 2 ways to make that happen. You can get a charged, then not, or you could have not and then a charged. So we're going to figure both of these probabilities to see what can possibly happen. So if I get a charged one out, that would be 3 out of 10. And then after I take out the charged one, that puts me over here, and I have one that's not, that would be 7 out of 9. So then the correct thing to do would be to multiply these probabilities in order to get this answer. Then, if I do this possibility, this would be 7 out of 10, and then the next thing would be 3 out of 9. So I would multiply these probabilities. After I multiply them, then I would add these numbers together to get the total. And that would be the total things that could happen. So this would be 7 over 21. And this is also 7 over 21. Nope, I'm wrong. 7 over 30. 3's cancel. So that if I add those together, I'd get 14 over 30, which is 7. And that would be the answer. And you could certainly divide that and make it into a decimal or a percent. Now, if you have a different form, then instead of having a 10 and a 9, you would have a 5 and a 4. Because you would start with 5 batteries and then put 4 batteries for the second. Most people did not get this correct. Some people did, which is nice. But that's what happened with that particular question. So does anybody have any question about this now? Again, it's not a really big deal. It's not going to come back. It's just one of those things. Many people did get number 2 correct. Some did not. If you say that the probability of having earbuds is 15%, what's happening if none of them have earbuds on? Well, the probability of yes having earbuds is 0.15. The probability of not having earbuds is 0.85. So then, if we say none of the people have earbuds, then that means it is this probability for each one of those people. And if it's 10 people, then that would be 0.85 to the 10th power. You will see a few things like this in the future, okay? So you need to understand how this works, that if something happens at a certain probability, if it does not happen, the probability is 1 minus that, and then for it to do multiple times. If it doesn't happen multiple times, then that means you take the probability of it not happening and multiply those things together. With regards to any of the other problems here, certainly the idea for number 6, that when I ask you the question, what are the unusual values of x? Again, most people got this, but what we're looking at here is that x is the thing that we're measuring. It's not the actual percentages or the probabilities. Those are not the values of x. So the answer to this one would be 0, 6, 7, 8, 9, and 10. Because those events, those measurements, have a probability less than 5%. Number 7, again, we went through this idea that for unusual values of x, we find the mean minus 2 standard deviations, then we find the mean plus 2 standard deviations. So it's not that, well, it's not anything else other than that. So you think about the mean, that's the thing that you kind of expect to happen the most, but to say what is the things that are going to happen 95% of the time, it would be between those two things. And then the formulas for the mean and standard deviation are given on the back there. So you would have that information. Yeah, most people were okay with number 8. Just a comment here. If you are going through a formula and you're going through the process of calculation, it's not actually necessary that you write down the intermediate steps. If you write down what your calculator gives you at the end, that's okay. If you wrote down what you put into your calculator at the beginning. Now, if you want to write down those numbers, that's okay, but it's also possible you can make a mistake. If you're writing down 8-digit numbers, then it's certainly possible for you to not get that right. So it's almost preferred that you find a way to trust your calculator to actually do that process of calculation so that you're not trying to enter 8-digit numbers when your calculator can keep track of that for you pretty easily. Okay? Because we're going to get equations that are a lot more difficult than this. And when you get to that point, you'll probably want to write down maybe one number on the top of a fraction and a couple of numbers down the bottom. But you don't want to go through all the steps, or you take you half an hour just the writing of everything down. So to get to the place where you say, okay, I trust my calculator to know what these numbers are. And showing your work is that you have the numbers in the right place in the formula. And then I expect that when you hit the buttons, you get down to the right thing. Now, that is a risk, I will admit to that, because if you hit something wrong, well, then it's all screwed up and it's all messed up. If you hit a plus sign instead of a minus or whatever. But generally, it's best for you to not spend a lot of time writing down intermediate steps of your calculation, if you can avoid doing it. All right, so what questions might you have about anything on the text? And it certainly is true that if there's something I made a mistake while I was grading, you can let me know, because I do make mistakes. I've made a couple even today, believe it or not. I know it's hard, but yes, I have. All right. Well, we'll go ahead and move on then. And we'll go ahead and work on what's in place here for homework set number 9, so that you can have an idea of how to make that stuff happen. If there's any questions about how to do anything on homework set number 9. All right, thanks. So if we go here, homework set number 9. And of course, my numbers on what I have up here is going to be a little bit different from what you have. But hopefully that's okay. Allow flash. Okay. So the first step here is to consider how to get z values from given areas. Does anybody need a table? I've got extras here. So the first step is that if we look at something like this, then we would recognize that the picture on our table, if we look over at the second page, we see that the picture looks the same as what we have right here. And so then we can get this number directly from the table just by looking it up. But we need to understand we're looking up the number in the area section of the table, on the inside of the table. And if I go to tables and formulas, then I can make that happen. Eventually, here we go. So then, as I said, if we want to find the z-score for an area, we look for the area number inside the table and figure out what z-score based on the left column and the top number, what z-score corresponds to that right there. So that is one skill that we need. So let's see if we can make this happen here. Find the z-score that I want something like this, and I want this to be, let's say, all right, so let's see if you can find these numbers here.
You have an extra calculator in your file for today?
I do.
Apparently didn't get put back in the back.
Don't.
No.
Sorry.
It's fine.
I usually try to keep two on hand, so. If you have one of those smartphones, you could also try that. All right, check with your neighbors, see what your neighbors got going on here.
No, that's just.
You get this number. Yeah. It's just 1.07.
Yeah, so like for this one, it's really here. So it's like 1.5.
No, I was told that, and that's.
All right, Chantal, what do you got for the first one?
I'm still working on it.
Okay.
The first one is 1.54.
1.54? Okay. That's correct. How about the second one, Casey? You got something for that?
Is the first one positive or negative?
The first one would be positive because this is to the right.
You take 1.
So then if you want to look on it from this point of view, you take 1 minus that.
Okay. I just wanted to.
And it was 1.54, is that
We
right?
do the. I think I did number 2 wrong.
Okay. So we want this to be the top 12%, so that would be 0.2. Mariah, you got something for me on that?
1.18.
1.18.
Well, I got 1.8800. I found one.
Okay, so we're doing 0.8800 is our area that we're looking at.
Yeah.
And we want to have something that's the closest we can to that, right?
Yes, and then it was 0.8810.
Okay, so we've got a 0.8810. And I think I can pull this up here just so we can all see it. Make it a little bigger here. No, a little smaller. Okay. Oh well, for whatever reason. So right here we got 0.8810. Do we have anything else that we might want to try?
The 8790.
8790 might work. Okay. Would we prefer one compared to the other one?
Are we supposed to use the higher one out of the two?
We are not necessarily supposed to use the higher one. We're supposed to use the closest one. So I want to know which one of these is closest to 0.88.
You're equal.
Okay. Who said they were equal? Was that you?
I did.
All right, Hillary. How did you know that they were equal?
Plus 10 minus 10.
Okay, so if I'm looking at 0.8800, and I say, if I add 10 of these digits, it would put me over here. If I subtract 10, it would put me over there. So they're actually the same distance from that. So then what would happen on a test is that I would say either one of these would be correct. Doesn't matter. If I'm using a computer, then I would actually get this to be halfway in between. And you might even say that, if you wanted to say that, you could, that I can go halfway in between these numbers, which would be 1.175. But that doesn't really matter that much. These things are all just approximate anyway. So it could be a z-score of 1.17 or 1.18. Either one. No big deal. And if you really want to say 1.175, that would be. All right. Any question about that process right here? Okay. So now we're going to extend this a bit, and we're going to say find the data value for the policy. So let's say I have lunch cost with a mean equal to $11, the standard deviation of 250, and I want to find the bottom 3% of that. And let's say I have a length of males where the mean is equal to 2.000. And I want the top 7. All right, so yeah, check with your neighbor, see if you got everything going on that needs to go on here. I don't know, I'm kind of cold. All right. Hey, Lynn, can you tell me how to start recording? Okay, negative 1.88 times 250. And then plus 11. Right there. 6.3. Okay. So that means that this right here is the z-score that corresponds to the bottom 3%. And so then when we look that up, hopefully, that's what we get. And then we do this calculation based on formula, which says that x is equal to z times sigma plus mu, or z times the standard deviation plus the mean. And in this case, since the z-score is negative, it's below the mean. That's what we want, we're at the bottom 3%. So then this number, all right, okay, then can you tell me how you would actually describe the answer? Not sure? Okay. Emily, can you tell me how you would describe your answer actually in this situation? What would you say to express your answer?
Pass.
Okay. Gabrielle, can you tell me how you would express your answer for this problem?
Pass.
Okay.
$6.30 is about 3% for lunch.
Not exactly. Anything less than $6.30 would be the bottom 3%. Okay? So when I say what data is in the bottom 3%, I would say anything less than. And you could say $6.30 or less, right? Doesn't matter, either way. All right. How about number 2? Melissa, what do you got for number 2?
1 minus 0.07, which gives 0.93. And then find the z-score, which is 1.48, and take that times the 0.004, and then add the 2.
Okay.
So then you get 2.01.
Yes. If we're looking at this and we say that these numbers go out to 4 digits, we're probably want to go out farther than that.
So then 2.00592.
Okay, so if we have 2.00592, that would be kind of a statement of our the specific answer that we get from this, okay? And then certainly on a test, I would say round it off to 4 digits or 4 places or whatever. As it turns out, when we did this process, remember I said that when we do the numbers from the table, we are rounding things off. So that if we were to actually use the computer to find the answer, it's actually 2.00590. So if you really need to be accurate in a situation like this, you would want to just use a computer from the beginning. And on Microsoft Excel, for example, or other spreadsheets, you can just put in the mean, the standard deviation, and the percent. And you'll use the normal distribution to just find the answer for it. So that's preferable if you're going to do this for a research thing or whatever. But for our purposes, this is good. All right. Now, this is the first part of what's going on in this homework assignment. The second part of what's going on is to use the sampling distribution. So what happens here? We're going to use a different formula. We're going to be using a different formula when we're talking about the sample mean. The sample mean, as we talked about before, it is bell-shaped in its distribution if we have certain things going on. So the sample mean is not exactly the same as the population mean. It could be higher or lower. But if we use the normal distribution, we can predict what values of the sample mean that we might have. So let's just say we're doing lunch costs, right? what did I say about that? I said the mean was 11, did I? And the standard deviation 2.5, right? So if I then say, all right, I'm going to take a sample of 45 people. Would I be surprised if the sample mean is more than 1150? Okay, that's my question. So let's see if you can make that happen. Okay. I have a data set, oh, and I'm going to say it's bell-shaped. Well, actually, I don't need to, do I? Because I have a high enough sample. I have 45 people, so it doesn't matter whether it's bell-shaped or not. So since it's 45, then I know X bar is bell-shaped. More or less. So now I want to try and figure this out. So based on what we did before, see if you can make that happen right here. All right, find out from your neighbor what they have for information. All right, Katie Larkin, what do you got for me? Yeah.
Okay, I got 0.0901.
So would you be surprised? No, because the percent is bigger than 5%. So, yep. So what we're saying here is that I have all these people, these 45 people, and I find out their lunch costs. And if it's $11.50 or higher, I would not be surprised by that, because this is 0.0901 up here. So that means it could happen, it certainly could happen that they have a high thing, but it's like, is this group like really big spenders for lunch? Well, no, I mean, you can't really tell. This is not a big difference from what I would expect it to be. It's certainly not going to be exactly 11, but it certainly could be higher than that, 11.50, that's not that big of a deal. But if you think about, it seems reasonable that like $12 would be a surprise. And so we could figure that out, but we're not gonna. All right, so now we're gonna take a break for 10 minutes. That'll bring us back here at 1:50. And then we'll talk some more about stuff. Might not have to take the whole hour, but we'll find out.